Alright, this video is going to work us through the acceleration solution for a word problem where we're given our information. So first thing we'll do is we'll read through the word problem. A car is riding down the highway at 40 miles per hour. While passing another car, it accelerates to 60 miles per hour in 5 seconds. What is the acceleration? Very straightforward, no real tricks here. First thing we do is we write out our acceleration formula. A stands for acceleration is equal to delta V over t. Now we talked about this. We want to remember that this symbol here, delta, which is really a triangle, in math language, it means to change. And the way we find change is through the operation subtraction. So in reality, this A equals delta V over t can actually be A is equal to the final velocity minus the initial velocity all over t. We have two velocities and we have to uniquely identify them through the little sub symbols here, the I and the F. So we have our equation. Now we write down along the side of the paper here, A equals VF equals VI equals T equals. And what we now need to do, we have everything all set up, is go through and work on our dissection of the word problem. Find out the information that the word problem has actually given us. So the first thing we say is a car is riding on the highway at 40 miles per hour. I've already read it through once, so I have a sense in my mind that the 40 miles per hour is in fact the starting velocity in this word problem. Trying to dissect the word problem without reading the problem through at least once is a little tough because you don't know if that 40 miles per hour is actually the final or the initial. But since I did, I know that it is in fact my initial velocity. So I'm going to identify that down here, 40 miles per hour. Okay? The next thing we do is we keep reading through. It says, while passing another car, it accelerates to 60 miles per hour in 5 seconds. So the 60 miles per hour is in fact going to be our final velocity, 60 miles per hour. Okay? And then in the 5 seconds, that's going to be our time. So we have our time down here, 5 seconds, and our acceleration is our question mark. So now we substitute. We'll do that up here. A is equal to. You have to make sure that you do this correctly, especially if the final velocity is a smaller number than the initial velocity. It doesn't matter. It always goes first. So we do A equals 60 miles per hour minus 40 miles per hour all over our 5 seconds. So we come down here again, A is equal to, first thing we're going to do is simple subtraction. 60 miles per hour minus 40 miles per hour is 20 miles per hour all over 5 seconds. Okay, this is a little different than we've seen in class before, but we'll talk in a second about how it still works out. The next thing we do is use our numbers. Our numbers go first. 20 divided by 5 is 4. Now look at our units. It makes sense. We have a velocity unit on the top, which is fine, and because we have a velocity unit on the top and we have a time unit on the bottom. So we have our velocity unit, our time unit. So it's 4 miles per hour per second. So there is no meters per second squared in this one because we were actually doing it with miles. If we were doing it with meters per second, the second would square and that would be okay. But what this is saying is that for every second of travel, the car was increasing its rate or its velocity by 4 miles per hour. So this is the unit of it. This is the unit that we would use when using miles per hour. I want to just show you quickly here though that when we do the math out another example, how it's actually meters per second squared. So let's say we have, I'm going to just give you the variables and we'll just do the solution together without a word problem. Okay, so A is going to be our question mark. We'll do a negative acceleration in this example. So the final velocity is actually going to be slower than the initial velocity. So assume a car came to rest. The final velocity is 0 meters per second. The initial velocity was 10 meters per second, and they did that in 2 seconds. I have my equation up here, and I'm going to substitute. So A is equal to this. You have to put this first. I know you're going to want to put the 10 first. Do 10 minus 0, but you can't. You have to put the 0 first, the V final first. So we do 0 meters per second minus 10 meters per second all over our 2 seconds. We now have A is equal to, we do the math out up here, it's going to be a negative 10 meters per second all over 2 seconds. And then we end up with right here, A is equal to negative 10 divided by 2 is our negative 5. The seconds can't cancel. They do not cancel because they are both on the bottom there. So we have meters per second, our velocity, all over our time. So this says to me that for every second of travel, this object slowed down by 5 meters per second, and it slowed down because of that negative right there. Another way to express this, and one that I will accept, is negative 5 meters per second squared.